Hi everyone, I welcome you all to the third lecture on thermal properties of matter. So today I am going to discuss the, in this lecture, I will be going to discuss thermometry and calorimetry. Okay, so let's start with the concept of thermometry. Thermometry is nothing but a measurement of a temperature, measurement of the temperature, or we can also say that measurement of the degree of hotness and coldness. Okay, that is also the definition of temperature. So we have most common three types of scale that are present to measure the temperature. That is Celsius, degree Celsius, Celsius scale, Fahrenheit scale, Fahrenheit, Kelvin, and Reaumur scale. So basically, four types of a scale are there to measure the temperature. Okay. So in all the scales, we have account it as a. So we have some reference state in all the temperature scale, and that reference state is considered to be the boiling point of water, boiling point of water and melting of ice, melting of ice. So in Fahrenheit, in degree centigrade, boiling point of water that is 100 degrees centigrade, and melting point of ice is melting of ice of the ice point that is 0 degree centigrade. Or we can say this point to be a high temperature, highest temperature, high temperature, and this is low temperature. So as the so melting of ice means to say that as you go just a few degrees, just more than 0 degree centigrade, the ice will melt. And at 0 degree centigrade also the ice will melt with the help of latent heat of vaporization, latent heat of melting. That is the phase change. So I will discuss all those concepts in the later half of the class. So that is degree centigrade. That is centigrade scale. Then we have Fahrenheit scale. That is degree F. This is degree C. So for Fahrenheit, it's 212 degree Fahrenheit to 32 degree Fahrenheit. For Reaumur, it's 80 degree R to it's 0 degree R. For Kelvin is 373.15, 273.15 Kelvin. Okay. That is the boiling point of water and the melting of ice. So now we need to see that how you can change from how can you change the scale of the temperature. Suppose if the temperature is given in some degree centigrade and you want the temperature to be in degree Fahrenheit, then how you can do that? Okay, so for that, if you see that if you let's suppose, so the easiest way to is to plot the two temperature scales. So let's say if it is Fahrenheit and if it is degree centigrade, then when it is 202 degree Fahrenheit and it is 32 degree Fahrenheit, then so this point is the boiling point of water. So in degree centigrade, it is 100 degree centigrade, and that is melting point of ice. That is, or the freezing point. You can say freezing point. That is 0 degree centigrade. Okay. No, sorry. It's if it is 32, then it's zero. Is here. That is zero. So now this point will be there. Okay. So this is this. This is melting point, and this is boiling point. Okay. Now let's say take some random point and call it C, comma R, and find out the slope in relation to that. Okay. So let me repeat this. So there is some confusion there while drawing this. So what I'm doing is I'm plotting the two scales together. So to scale is, and then I will generalize it for the other scales. So let's say degree Fahrenheit is here, degree centigrade is here. So at 0 degree centigrade, it's 32 degree Fahrenheit. So first point is this. Okay, now at 100 degree centigrade, it's 212 degree Fahrenheit. So another point is this. Okay, so so if you join these 2 points, these are the points. This is the line between the melting point of ice to the boiling point of the water. Okay, so the thing is that we know the melting point of ice and boiling point of water in many different units, and so from that we can convert it with each other. Okay, so here is 32 degree Fahrenheit. It's 212 degree. Now let's take some random point, that is degree centigrade and degree Fahrenheit. Then the slope of this line is same. So what will happen is the slope of this line, if you take these 2 points to calculate the slope, so the slope will comes out to be 100. So this point is 100, comma 212. This is 0, comma 32. So if the slope of the line is this minus this, 212 minus 32 divided by 100 minus 0. And then slope from here to here, that is f minus 32 divided by c minus 0. So from here we get a relation between. Okay, so we can relate f and c from here. I'm just checking. So 212 minus 32 will become 180. 180 divided by 100 is equals to f minus 32 by c. So c comes out to be 9 by 5. C comes out to be 5 by 9 into f minus 32. So in the same way, you can relate other scales. So similarly, if we know this, so let's say 212 is for the Fahrenheit. Now instead of Fahrenheit, you have this Roman scale and you want to convert it to degree centigrade. So 80 minus, so boiling point of water minus freezing point of water in Roman. So that is 0 divided by 100 minus 0. You want it in degree centigrade is equals to R, some random point, minus 0 divided by C minus 0. So C comes out to be 80 by, so C comes out to be 100 R by 80. So C is 5 by 4 R. Now let's take another, let's take this Kelvin. So Kelvin is 373.15 minus 273.15. So that is the boiling point minus melting point divided by 100 minus 0 is equals to K minus, so Kelvin is there. So Kelvin minus its melting point. So that is 273.15 and that is 373. So that is C minus 0. Okay. So from here that comes out to be, C comes out to be K minus 273.15. So if something is given in degree centigrade, then you need to add 273.15 to get that in Kelvin. So that is C plus 273.15. Okay. So these are the concepts of thermometry. So let's take some questions for that. So question R, convert 27 degrees centigrade in Kelvin and Fahrenheit. The only thing, if you know the formula, that is good. But if you don't know, that is also okay. You just need to find out the generalized formula. So we need to because we know how to get the formula. We know the melting and boiling point. So 27 degrees centigrade in Kelvin. So for Kelvin, it's easy, very easy. So Kelvin is 27 plus 273.15. So that is 3. So for Kelvin, I am writing this for Kelvin, degree to Kelvin, degree centigrade to Kelvin. So 27 plus 273.15. That is 300.15. Now for degree centigrade to Fahrenheit, we have C is equals to 5 by 9 into F minus 32. So C we know that is 27. We need to find F. That is F 5 by 9 into F minus 32. 27 into 9 divided by 5. We will finish to F minus 32. So F comes out to. So just solve it and you will find out the answer. I'm not doing the calculation. Plus 52. So that is, so this comes out to be degree Fahrenheit and this is Kelvin. Okay. You will get the same thing if you don't know this formula also, because we know the boiling point and the freezing point. So we know, so that is 212 minus 32 divided by 100 minus 0 is equals to centigrade. No, we know so that is F there. So F minus 32 divided by C minus 0. So C we know that is 27. So F comes out to be 180 divided by 100 into 27 plus 32. You get the same stuff, 27 into 9 by 5 plus 32. And you can solve this. Okay. So now the question is, if the temperature is changed from 30 degrees centigrade to 60 degrees centigrade, then find the value of delta T in Kelvin and Fahrenheit scale. Okay, so we know the boiling point for and the melting point for degree centigrade. So that is, let's take this approach. So that is for degree centigrade. For Fahrenheit, it's 212, it's 32. For Kelvin is 373.15 and 273.15. Okay. Now, what do we need to do is, that is degree centigrade, Fahrenheit and Kelvin. So that if there is a change in boiling point to melting point, that is 100 degree. So for a 100 degree centigrade change, there is a change in 180 degree Fahrenheit and there is a change in 100 degree Kelvin. So we need to convert the change. So here what we have given, delta T is 30 degree centigrade. So if you need to convert it for, if you want it in Fahrenheit, so we know that for 100 degrees and change, it's 180 degree Fahrenheit change. So 1 degree change is 180 by 100 degree Fahrenheit change. So 30 degree changes, that is just the unit of system, 180 divided by 100 into 30, that is 54 degree Fahrenheit. Okay. Now, for the second case, let's look at the second case. So that is, we need to find it in Kelvin. So 100 degree centigrade change to, so it is 100 degree Kelvin change. So 1 degree centigrade changes 1 degree Kelvin. So 30 degree centigrade changes 30 degree Kelvin. So answer is this for in terms of Kelvin, and degree Fahrenheit for in terms of Fahrenheit. Okay. So that is the thermometry. Now let's start another concept, that is calorimetry. Calorimetry is basically the study of measurement of heat. Okay, that is called to be a calorimetry. So the concept of calorimetry, let's look at what is specific heat. So before going to the specific heat, I want to make you a feel of the concept of calorimetry. Suppose we have given a material, let's say some whatever you say. Let's take steel, and you are heating it uniformly, heating it uniformly. And let's say it is at room temperature initially, T is equals to 0, it is at 27 degrees centigrade. And for some times T, it becomes, so that is the steady state temperature, it becomes 28 degrees centigrade. So the delta T change comes out to be 1 degree centigrade. So we need some heat to raise this temperature to 1 degree centigrade. So the amount, so we need some heat to raise the temperature of steel bar by 1 degree centigrade. But that amount of heat is also dependent upon the amount of steel. So let's say the amount of steel is 1 kg. Okay. So we need heat to raise the temperature of steel by 1 degree centigrade. Better to say, so we need some heat to raise the temperature of a steel bar of of mass 1 kg by 1 degree centigrade. So that heat required to raise the temperature, raise the temperature of body is called specific heat. So more specifically, specific heat. I want you to introduce the concept of the specific heat. That's why I'm telling this thing. So the specific heat it is defined as the heat required to raise the temperature of 1 gram of body to 1 degree centigrade. Okay, so that is we call as specific heat. Whenever you see the term specific, it means per unit mass. Okay, so specific means per unit mass. Whatever you see, it's per unit mass only. Here, that's why specific heat is called to be a 1 gram of body to 1 degree centigrade. And it can also be defined as, it is also the ratio of heat capacity, heat capacity per unit mass. And that's why it's called as specific heat. Okay. So if you compare the conductor, so if a substance, I want to point out few things here. A substance having a low heat capacity are considered to be the good conductor of heat. So in general, conductor is having a low heat capacity. So now, what is the use of this concept is, suppose you have given a mass, let's say just as I just told you that let's say this is a steel block. So the mass is 1 kg. So we need to find out, the question is the amount of heat required to raise the temperature of steel block by some degree of centigrade. Let's call it M mass. So we need to derive a generalized formula. Steel block by some degree centigrade. So we need to find out the Q. So that is nothing but mass into specific heat into delta T. Because C is defined as per unit mass and per unit degree centigrade. So we can also write this as M delta T into C. So C is defined like this. So C is the specific heat. So we need to find out the Q. So we need this specific heat to find out the amount of heat required to raise the temperature of a steel block such that the net change in temperature is delta T and the mass of the block is M. Okay. So that is the concept here. So now let's look at some questions related to that. The questions are: find the amount of heat required to raise the temperature from 10 degrees centigrade to 40 degrees centigrade. Specific to raise the temperature of water from 10 degrees centigrade to 40 degrees centigrade. Specific heat of water is 4.2 joule per gram degree centigrade. We need to find out Q, so that is M C delta T. C is specific heat. So C is specific heat, delta T we know, and the change in temperature we also know. Okay. What we don't know is mass. The mass is also given, that is 2 gram. So we need to find out Q. The Q is 2 gram because specific is given gram, so that's fine. Temperature is also needed to be in degree centigrade. So delta T comes out to be 30 degrees centigrade and 2 into 4.2 joule per gram degree centigrade. So that is 2 gram and degree centigrade is 30. So it comes out to be 25.2 joule. Okay. Now look at the next question. So heater gives heat at a rate of 100 watt. It is used to heat 50 gram of water from 20 degrees centigrade to 30 degrees centigrade. The specific heat of water is 4.2 joule per gram degree centigrade. Find the time taken to raise the temperature. So I told you that watt is nothing but joule per second. So Q is, that is watt. So that is joule per second. So here Q is H into T. So that is watt into second. Okay. So where I am telling you that Q is from the heater, that is 100 into T, that is joule per second. So that 100 is joule per second into time, that is second. So that time should be in second. So that will make it to joule. And I'm saying that by balancing the units, so it is very important to balance the units so that you will not do those mistakes, that conversion mistakes. So I am telling you that it's better to have to put all the units together. So what I have shown you that a gram will cancel out with gram, degree centigrade will cancel out with degree centigrade, joule with joule, and time we know that it is in seconds. So that's why the time, the second is also cancelled. Okay. So here we need to find T. That is simple. So from here we can get T comes out to be 50 into 4.2 into 10 divided by 100. So that will become 21 seconds. Okay. Now I will be going to introduce the principle of calorimetry. Principle of calorimetry. So according to principle of calorimetry, we may also call it as method of mixtures. Method of mixtures. So it is heat lost by hot body must be equal to the heat gained by cold body according to the principle of calorimetry. So as we also know that there shouldn't be any loss of it, it is equal, it looks like a similar to the conservation of energy, or so everything is conserved basically. So there is no loss of heat. So let's understand it with one of the question, that is 160 gram of water at 80 degrees centigrade is mixed with 40 gram of water, 40 gram of 40 gram of copper at 10 degrees centigrade. Find the final temperature of mixture. That is a dummy problem because you see copper is cannot be directly mixed with water. So that's a dummy problem to understand the mixture, the concept of mixtures and what will happen when there is a transfer of heat. So as according to the principle of calorimetry, the heat, so water is at high temperature, so the heat lost by water, heat lost by water should be equal to heat gained by copper. So that this heat is mc water into delta T, and this is mass of water, and this is mass of copper, specific heat of copper into delta T. The mass of water is 160 gram. Specific heat of water is, so that is 4.2 joule per gram per degree centigrade, and copper is 0.4 joule per degree centigrade per gram. So that is, for water it's 4.2 into change in temperature. So we don't know what is the final temperature we need to find. So that let's consider it to the final temperature of mixture is theta. So that is theta minus T of water is equals to mass of copper. So that is 42 gram, not 40 grams, 42 gram. So that is 42 into specific heat of copper, that is 0.4 into change in temperature. So that's the final temperature. Uh, I think here it should be 80. It's going from 80 to theta. Final temperature is theta. Here it is. Theta is become the final temperature, and that is copper is at the lower temperature, so that is 10. So let's solve this. It's in gram, it is in degree centigrade, that's fine. So this become 10. This will go. This will come also, so this will go. So 42 will go with 42. So 40, it comes out to be 40 into 80 minus theta is equals to theta minus 10. 3200 minus 40 theta is equals to theta minus 10. So that is the 41 1 theta is equals to 3190. We can calculate 3190 divided by 41. So this is the final answer in degree centigrade. Okay. So in the next class, I will be going to start with the concept of latent heat. Okay. So I will start with latent heat. Why it is important, we'll let you know. And also followed by the conduction. So I will try to cover these two topics in the next class. Okay. Thank you.